All right, so we're talking about rate of change here. Rate of change. Now, you know rate of change as slope, and you know slope from your previous experiences in Algebra 1 and 8th grade math. We have a formula for slope. It's m equals y2 minus y1 over x2 minus x1, but I'm going to change it up a little bit because with slope, we're looking at a constant rate of change of a linear equation, but when we're studying polynomials, what we're looking at is instead of finding the slope of a straight line, maybe finding the slope of any two given points along a polynomial, because any point on this polynomial has a certain rate of change, and if you go on to study in a calculus class, you'll see that the rate of change can be instantaneous. So it's right here, it's got a positive slope, and here it's got a negative slope, which kind of relates to our discussion on increasing and decreasing. But what we can find, though, instead is an average rate of change. So like from here to here, we have a positive slope, an average increase. So we're going to kind of change this up just a touch. We can say that the slope is kind of also equal to, on the bottom we still have x2 minus x1, but on the top, we'll think about it from a function standpoint, f of x2 minus f of x1. Now, remember that f of x is equal to y. They're the same thing. So here, f of x2 and y2 are the same, and f of x1 and y1 are also the same. And additionally, we'll go one step further here. We talked about interval notation. This is like a comma b here, meaning from -6 to -1, including -6 and -1. We could use interval notation here as well, or not necessarily notation, but the letters a minus b. Let's fix that little comma there. A minus b on the bottom, and on top we would have f of a minus f of b. Again, this is just the slope formula. So in this first example here, it says, given the function h of x equals -x squared minus 10x plus 29, determine the average rate of change of the function over the interval. So this is a quadratic. It's upside down. I know that because of the negative. So it's got different rates of change depending on where you are, but I want to know the average rate of change from -6 to -1. So what's great is I have half of my answer here. The bottom of the slope formula is x2 minus x1, or a minus b, so I can just put down here -6 minus -1. Now I'm going to separate those negatives with a set of parentheses because I think that's important. Now I need the y coordinates. How do you get the y coordinates if you've got the x's in the equation? Well, you substitute them in. I need to take -6 and substitute it in for x here to get a y, and I need to take -1 and substitute it in here as well. So this is h of -6 minus h of -1, whatever I happen to get. So let's do that. Let's find h of -6. That's -6 squared. Remember, I'm going to be very liberal with the parentheses when I'm dealing with negatives here. Then I've got times -6 as well, plus 29. All right. Now, let's see. This is 36, positive 36. Make it -36 plus 60 plus 29. And I believe we did this already. That ends up being 58. Sorry, I just did the math. I was worried about that. That's 53. I had to pause for a second. That's 53. I'll pull the calculator out next time. H of -1 is very similar. It's -1 squared minus 10 times -1 plus 29. So it's important to see there that we're just taking this number and putting it in for x here. And then same thing. It's the same equation except -1 this time. Let's check it on the calculator just to be sure this time. I've got -1 squared minus 10 times -1 plus 29, and that is 38. And that matches with what I did yesterday. So that's equal to 38. Now I've got these two numbers here, and I can just put them in these respective positions. So I'll have 53 minus 38 over -6 minus -1, and that is -3. Feel free to use a calculator on that one. That's okay. Now here's what's great. In a table of values, your x's and your f of x's are already found for you. So notice that it says, given the function defined in the table below, find the average rate of change of the function over the interval 0 to 4. Well, I know my x is here and my x is here. That's like x1 and x2 or x2 and x1, right? I don't have to plug anything into the function because that's what a table of values is. If you plug in 0, you get 3. If you plug in 4, you get 48, and those numbers get dumped directly into my formula here. 3 minus 48 is y2 minus y1 over x2 minus x1. That's 0 minus 4. And interestingly enough, when I did this one, I realized that I got something ugly here that doesn't simplify or anything. That's just 45 over 4. Rise over run. It's really ugly, but that'll work just fine. Speaking of rise over run, I said that just a moment ago. I like to take a look at these from a graphing standpoint as well. Notice here I've got an interval from -2 to -1. -2 is right here, so I'm looking at this point. And -1 is right here, so I'm looking at this point. Now, I know something already. I know that my slope, whatever I find, is going to be negative. Now, I can take these points here and find their coordinates and plug them in, but what if I just try to find the rise over the run? Rise over run, right? Now, in this case, my rise is actually a fall, right? So that's negative. So let's take a look here. The scale here, every unit on here is 10. So it looks like I go down from 10 to -10. So that's a run, or sorry, a rise or a fall in this case of -20 over a run of 1. And look at that. That's just -20. Okay, remember that this thing's going to have different rates of change. Like the slope here is positive, yeah, but look, I could look right through these 2 points and have a very similar slope. Okay, or maybe right here it's negative, or maybe right at the bottom here, maybe it's 0. Okay, if you study calculus later, you'll see a little bit more of that. Okay, but average rate of change is just a description of how it changes over an interval.